So yes guys, so now we will see the baby step number 3. So basically here we are creating a Makefile. So let me copy this one, so empty Makefile, and also the C source code. I'll paste it here. So let me minimize all this thing. So here, as I said in the earlier second video, the Makefile name should be case sensitive. It is case sensitive. So basically it should start with capital M, rest everything is a small case. So then main.c, so here we are simply I'm printing a hello world and there is a test here. Now let us see how can we write a Makefile. So it is different steps, right? So what exactly we will do? So we will do step by step. So during the first stage of a compiler, what exactly we are doing? So we are taking this one, gcc hyphen capital E, then we are taking main.c, then it will generate what? main.i, intermediate file, right? So basically this is called a rule, what exactly we are writing. So enter one tab. So without tab, it won't work. So it should be tab and it should be in the next line. So now what exactly it will generate? It will generate what? main.i and put a semicolon. So this is basically a first rule. So now let's go and see like whether really it works or not. So what exactly I'm doing here? Again, I'm repeating. So this is the output, which is main.i. Then in the next line, I have to put a semicolon. So let me increase the font a little bit. So I have to put a semicolon. Then I have to put a tab. So it is not 4 spaces. It is exactly a tab. Then I have to give gcc capital E main.c. Then redirect this one to an intermediate file. Now let's go to my terminal. And in order to compile this one, so let me go back to my baby step 3, enter. So now in order to compile this one, you must install a make. So make command. So basically in order to do that one, what you have to do is sudo apt install make, enter. So in my case, it is already been installed. So I no need to install it again. In your case, if it is not installed, you need to install this make command. Then what you have to do is simply execute make and space, then give what exactly this rule you are defining here. So the target. So basically main.i, right? So paste it. So basically our main.i, enter. So once you do this one, can you see this step is getting printed? So I do ls, can you see main.i is getting generated. So main.i, the intermediate file is getting generated. I'll close this one. Let me go and delete this one. Again, we will go here. So simply let's say make. So the moment if I do this make, if I do this ls, can you see again here also there is an intermediate file is getting generated. So simply by executing this make, so what exactly it will do is, so it will start executing all this thing. So it will see main.i is the target I want. Then I can give, it will execute this command, the output will be main.i. So either you can give the make and exactly the rule name, which is nothing but main.i, or simply you can give a make. So now can you see make I is already updated. So nothing is changed. So that's why it is saying it is already updated. So this is the power of a Makefile. Now let us go to the next step. So what is my next step? Main dot assembly code, right? So in enter here, put a tab, gcc. So how can I generate? Hyphen capital S. Then input is main.i. So then I no need to redirect. By default, it will generate. Correct, right? So again, go here, execute, make. So now if you see only main.i is getting generated. Now I need to do make. Then I'll say main.s, enter. Now the moment you do this one, can you see main.s is working fine. So why this one worked and why this one did not work? So that is how this make works. So basically, so in order for this one, for this main.s to do, so it needs main.i. So let's do one thing. So let me remove these two things. Then I'll go to this Makefile. So let's execute main.s. Now the moment I execute main.s, can you see there is no such files or directory. So that means first I need main.s, main.i intermediate file as an input to this guy. Then I can generate main.s, right? So now if I do simply a make, if I do simply a make, what exactly is happening? So only the first step is executing, only this first rule is getting executed. So not this one. So that's why for this one, what we have to specify with the space is what is the dependency. So for this main.s, I need main.i. So then only I could go and execute. So now it will find whether main.i is exist or not. If main.i does not exist, so then it will jump to this rule, then it will execute this one. So now let's see. So I'll delete this one. Again, I'll go back. Simply if I say make, so it will execute first rule. Only this rule and exit. That's it. Now, what I'll do is make minus, like let's say ls. So make.i is there. I'll say remove this main.i file. Now I'll say main.yes. Enter. Now can you see? So since I give a dependency here, whenever this rule is getting executed, it will try to search for this dependency. If this dependency is already generated, then it will go and execute this part. So in my case, this dependency is not there. So that's why it went here, it generated it, run this rule. So basically it is running this command and output is main.i. Then again it came back and it is executing this one. This is how we are giving a dependency. So now you might ask a question, main.c is also needed, right? Dependency. Yes, exactly. So you give main.c. If you delete this main.c and simply execute this one will also give an error saying main.c is not found. Now let's go to the next step. So main.o. So this is my object file. Now you know, right? So what is the input for this one? Main.s. So this is the dependency. Now I'll say gcc-c main.s. This is my input. Correct, right? Now this is how it works. So then let's go say main.o. Enter. Now can you see? So -c is been getting executed. So main.o is also there. So the object is getting generated. So now what is the next step? So my a.out, right? So I'll say a.out. So for this one, I need a main.o as a dependency. Enter gcc main.o. See, simply give like this. Again, go to this Makefile. I'll say make a.out. Enter. Now if I compile, if you see this ls, so I have a a.out working fine. So now what I'll do is a.out, main.i, main.object, everything. So all the intermediate files I deleted. So only have a Makefile and have a main.c. Now what I do is I'll say make a.out. Enter. Can you see? All the dependency steps, step by step, everything is getting executed. So now if I say ls, so we have a.out, so which is coming from my Makefile. If I again execute make a.out, can you see a.out is up to date? But how it is coming to know so it is up to date? So the simplest thing what exactly it is doing is, so if I say have a ls minus lam, so nobody has changed this source code. So that's why it is not recompiling it. So it is intelligent enough. How it knows it should not recompile? Because it is looking for the timestamp. So this one main.c, it is looking for the timestamp. So it is not updated. So let's say I'll update this one. So by doing a touch, so basically you are updating a timestamp. So now if I say ls minus lam, so earlier main.c was 16.5. Now this main.c is 16.12. So let me execute make a.out. Can you see? I did not even change the source code. I simply touch. So that means make is looking for whichever the file where the timestamp is updated. So that means it is doing a stat on this particular rule. So whatever the output we are giving, and if it is updated, all its dependency has been changed. All its dependency has been recompiled. So if that is true, let us not update main.c. Instead of that one, let's update main.i. So then obviously the compilation should start from here, right? Let's see that one. So what I'll do is I'll say now this main.i is 16.12. So let's touch this main.i. Enter. Now again execute make a.out. Can you see? It has skipped this first step. So it started from main.i. So that means wherever it goes and touches, so you make a changes and simply you save it. So it will rebuild the entire stuff. So wherever you are touching. So that is also one of the stuff optimization it has been done. So simply it will not compile all the files. So it will simply not go for all the steps. The steps I only defined, but depends on the timestamp. It is doing all this stuff. Now you understood, right? Now one more thing, what exactly usually the normal way of building this one is, so instead of a.out, people will give something called all. Then here I can say my output is maybe hello. Now instead of saying make or something. So I'll say make all, enter. So since only some part of the things are being touched, so that's why that is touching only that piece of code. So let me delete all other stuff. Hello, a dot out. So let's keep only main.c. So now let's execute main.all. Can you see? Not main.all. So basically make all. So this is how you will see in the real-time projects, right? So make all means, so it is executing all these steps. So again, if I do this make all, so only this object file is getting generated. So that means only the last part is getting run. So whenever you are running all, so anyway main.o is already been updated. So I no need to generate this main.o. Simply it is regenerating this hello BR because we are explicitly asking for it to do this one. Now one more thing is, now I generated all this thing, but how can I do the cleanup? Let me create my own rule. So let's say clean. I'll say rf minus rf. I'll say main.i. Please delete this main.s and please delete this main.o and also please delete hello. So please remove all these files. So that is what this make clean is doing. So now if I say make clean, can you see? ls, now the build system is completely clean. Now if I say simply make, so again it is jumping and executing only the first step. So then what I'll do is, instead of this one, let me keep this one on the first line. Got it, right? Because it is executing only the first line and it is coming out, because it is not going for the next step. So whenever I simply execute make, that's why I moved this all to the first line. Now let us see what happened. Before that, let's clean. So let's say clean. Yeah. So now everything is clean. Simply execute make. Can you see now? So beautiful, right? So now since I moved this all to the first line, so first it is going and checking all. So main.o, is it generated? No. So it went here. So then main.s is a dependency. So is it generated? No. It went here. Main.i is a dependency. It is generated? No. Again it will come here, main.i. So do I have a main.c? Yes. Then execute this one. Then main.i is getting generated. Now this main.s will get generated because I is already present. So it will come here. Then again it will go to this step. It will generate an assembly code. Now again it will go back. Main.object dependency has been resolved or it is compiled. It is present. Then it will execute the last one. Now you know like what exactly, either you can give make all, so this is the best practice, or you can put the last item, so which you are getting output on the first line, basically the first rule. So now if I say make clean, so it is working fine, and make, so ls, and let's say make all. So this is how it is working. And even if you want to execute some command, let's say you want to execute the entire source code itself here, not source code, basically output. Yes, you can say exec or anything you can give. It does not matter. So I'll say execute. I'll say hello. Let's say make execute. Can you see? Hello is getting printed. So this is how, guys, the Makefile system is being built. So now if you want to change this one to a C++ compiler, so just everywhere replace this one with a G++. Now what exactly the C++ guys will do is, so basically instead of GCC, they will say CC or CX is equal to some variable they will declare. Let's say GCC or something like this. Then wherever they are using, so everywhere they will say CXX or CX, something like this. So let's say whether really it works, make clean and make all. Can you see? This is how they are doing. So now what they will do is, they will take this, replace everywhere wherever the GCC is there. So yes, that's it. Now, then what I'll do is, so I'll say make all. So it is all working fine. So make clean. So yes, it is working fine. Now what if I decided to change the compiler? Just I need to go and change here, right? So instead of GCC, I can put a CLang here. Now again, I'll go back. Let's say make clean before doing anything. So ls nothing is there. Let's say make. Can you see? So instead of GCC compiler, now what? Just within one line, I change the entire compiler. So using this one. So I'll be not completely teaching you the entire Makefile system. So what I want you to understand is, so these are all the compilation steps involved. Then slowly we build the Makefile, and this is where in the real-time product you can see there are a lot of places. So where The people are hard coding, like how they are getting the compiler at the runtime. So basically, simply they are changing this variable. So rest everywhere it will be changed. So simply instead of C line, so what if you give a cross compiler rmgcc something, so that will get executed. So basically that is how it works. So if you want to execute, compile and execute at one shot, so simply put your command here. So below the all, so it will compile and it will also execute. Let's say make clean. Let's say make. Can you see? Hello, and hello word is getting printed. So yes, guys. So this is what the fundamentals of this Makefile, and this is very much and very important for you to understand the basics of CMake. Hope you understood. So let's meet in the next baby steps.